Only a few kilometers away from the site of the climate conference in Bonn, these COP23 participants went on an excursion to see theory put into practice. They are visiting the student dorm 42 close to Bonn University. Climate protection in the building sector is essential in achieving global climate goals. The United Nations explicitly designate the Passive House standard as a way to increase the energy efficiency of buildings. The Bonn student dorm shows how highly energy-efficient construction is already possible today. We have done the math to find out what the most economical system is: biomass, heat pumps or even electric. This has been compared over the component's life cycle, which means not only calculating the manufacturing costs, but also the expected future costs. Of course, the PHPP is an incredibly useful tool because it allows us to reasonably estimate and calculate future results and costs. And of course, we also took things such as vacancy times during the semester break into account. At the end of the day, it was actually the smallest heat pump with a small underfloor heating that turned out to be the most economical system. The roof and the exterior walls of the Passive House building are insulated with about 30 centimeters of cellulose from recycled newspaper. A centralized ventilation system with heat recovery provides the student apartments with fresh and preheated air. At the same time, residents can of course open their windows. The participants of the COP excursion also looked at the property's garden. It is not only a place to grow vegetables, it's also a place to collect rainwater for toilets. I think it's great that all aspects have been implemented holistically, and I think this is an example of architecture as it should be today, especially against the backdrop of the COP here in Bonn. This is sustainable planning and construction. It's also great to see the successful integration of civil engineering and architecture.
It's a lot of innovation, a lot of brain before the design phase, I think. And at the end, it's a an excellent use of low-cost technologies, I would say, which definitely bring some added value to those who are living into this building.
The student dorm 42 combines energy efficiency with ecology. For this, the architect and investor installed a photovoltaic system on the roof area. The electricity from solar energy is temporarily stored in batteries. In summer, the underfloor heating can cool the building if necessary. For this, the direction of the heat pump is simply changed. Hot water is heated electrically. And what happens if 32 students want to take a shower at the same time? The monitoring proves that this does not really happen in practice. We've discussed with the municipal works about the so-called concurrency factor. The students do not shower at the same time, so practice shows that this works and the energy provider had no problem with it. We didn't need to have an oversized cable and the connection costs were not inflated. There is a little more electricity that we get into the house, and yes, we also had to open the road to lay a new cable, which of course is not normal, but again, over the long term it is a very efficient technology. Thanks to new electronic devices, we only have to heat the difference between cold water temperature and shower water temperature. This is so efficient that the concurrency factor does not cause any problems at all. It's not worthwhile to bill each inhabitant for the already low energy consumption. The students therefore pay an all-inclusive warm rent. The Passive House dorm is also a smart home. For example, building automation knows how many people are in the building at the same time. It also controls the room temperature and ensures proper shading during summer. And if necessary, the smart home communicates with its inhabitants. The students are coming from their parents' homes, and very few of these buildings are energy efficient. The students themselves have a very high affinity with sustainability, and they understand it too, but you have to support them and take the users along on the journey. We have a microcomputer with very little background technology based on industry standards. We have installed inexpensive sensors throughout the building which help to measure and support building automation. If, for example, students leave their windows open for too long, the house will simply write them an email and remind them that we have a ventilation system with heat recovery that can provide much better fresh air than leaving the window open all day. The construction of this passive house building cost the investor less than 1,500 euros per square meter. These comparatively low construction costs, combined with high energy efficiency and sophisticated technology, also impressed the participants of the COP excursion.
What impressed me first that there is a lot of intelligence to design this building, and this intelligence enabled to build this high quality building for 1,500 euro per quadrat meter. You can do high quality with not so much technique for affordable.
I really love the fact that you have almost no power to build, to heat up the whole building, and that they really thought about all the single details, like use of rainwater. I really like this.
The energy efficiency of the building has also been noticed by the jurors of the Green Building Solutions Award. During the UN Climate Conference, the Passive House Student Dorm received one of the awards for very innovative projects.